Hello, geometry classes. Lesson 11.7, we're going to be finding the volume of pyramids and cones. And you're going to see quite a bit of connection between the volume of our pyramids and cones compared to our prisms. So basically what we're going to be doing is we're going to be taking our prism formulas for finding volume, and we're going to multiply those prism volumes by 1/3. So let's see how this works. Theorem 11.9, volume of a pyramid. Well, the volume of a pyramid will be 1/3 of the base times the height, and you're going to recognize base times height as the formula for the volume of a prism. Basically what's happened is, if you can imagine, we've taken a rectangular prism, put it into an interesting kind of pencil sharpener that's a very large sharpener, and we're going to sharpen it down to a point here. And it turns out there'll be 1/3 of the volume of that rectangular prism left. When you get to calculus, you'll be able to prove that quite easily. At this point, we're just going to make the observation that there will be 1/3 of that rectangular prism left when we sharpen that rectangular prism down to a point, and it becomes a pyramid. So the volume of this particular pyramid will be 1/3 of whatever the base area is. In this case, it looks like it's a square, so the area of that square times the height. Doesn't matter what the base is, you'll find the area of that base, multiply times the height, which will be perpendicular to the base, times 1/3, and you'll have the volume of that pyramid. For theorem 11.10, we're going to look at the volume of a cone. It's actually the same basic idea. The volume will be 1/3 of base times height. Imagine a cylinder put into a special type of big, huge pencil sharpener, sharpened down to a point, and the volume of that cylinder will be reduced down to just 1/3 of what it was originally. So again, in calculus, you'll be able to easily show why the relationship is 1/3 of the volume of that cylinder, but for right now, we're just making that observation. So 1/3 of base times height will give you the volume of that cone, and the base of the cone will be the circle, so pi r squared for the area of that circle. So volume of a cone is 1/3 times pi r squared times h. All right, let's go ahead and work out some problems with these formulas. So example 1 asks us to work out two different volumes. The first volume is the volume of this triangular pyramid. So the formula that we'll use, of course, will be 1/3 base times height. The base is a triangle, so we will find the area of the base of that triangle by using 1/2 base times height. And that little h, I'm going to rewrite as big H to distinguish it from the height of the triangle. So the big H will designate the distance between the point that it comes to and the base. And of course, that will be a perpendicular distance between the point at the top of the pyramid and the base at the bottom. Plugging in our numbers then, 1/3 times 1/2 times the base of the triangle is 4. The height is 6. It is a right triangle, so we can use those legs as the base and the height. Times 9, and that would be the distance from the point down to the base. Now we simplify this out, and let's see, we'll have 1/3 of 9 is 3, half of 4 is 2, times 6, and 3 times 2 times 6 is 36. Now we're counting cubic meters, meters cubed. Make sure that you designate what you're counting here. Don't just write V equals 36. That won't be enough when we're given specific information about the units that are being used to measure the figure. Okay, letter B is asking us to find the volume of an oblique cone. So it's a cone that's been tipped on its side, and we learned from Cavalieri's principle in a previous lesson that we can find the volume of that cone by using the standard formula for the volume of a right cone. Right cone would be that the point of the triangle, the point of the cone would form right angles with the base. So here we are told that perpendicular distance is 4.5 centimeters. We're told the radius is 2.2 centimeters. So we're going to plug into this formula, 1/3 base times height. The base is pi r squared. The height will be that perpendicular distance from the point down to the base. And the radius is given to us as 2.2, so we're going to square that radius, putting in 2.2 for r. We're told that that perpendicular distance, the height, is 4.5. So then we're going to go ahead and do some simplifying. I'm noticing that 1/3 of 4.5, I can think of that as 1/3 of 45. 1/3 of 45 is 15. Put my decimal point in, and that 1.5 then represents 1/3 times 4.5. 2.2 squared, I can think of that as 22 squared. I know that 22 squared is 484. put the 2 decimal places in because we have 2.2 times 2.2, 2 decimal places, and multiplying that out gives us 4.84. At this point, I'll use my calculator to multiply 1.5 times pi times 4.84. I will use 3.14 in my calculator for pi, which means my answers are going to be a little different than what you see in your textbook, which uses the pi button on a graphing calculator. Volume then on my calculator shows as 22.7964. The 6 here is going to make this 9 round up, but oh, wait a minute, 9 rounds up to 10, so we'll have to think of that 6 rounding up 79 to 80. So 22.80 centimeters cubed will be the final value that we will give for the volume of this oblique cone. Next one, example 2. So here we have a square pyramid. We're told its volume, and in your textbook it's talking about this as one of those Egyptian pyramids, which is huge, so that's why you see the big number here. And originally it said it had a height, that's from the point at the top here, perpendicular down to the base. That's 144 meters, so it's very, very tall, and the volume is huge. And we're asked to figure out, well, based on the volume of this pyramid and based on its height, what would the length of each of those sides be, assuming that's a square as a base? Well, we're still going to use our same formula to work our answer out. Volume is 1/3 times b times h for the volume of a pyramid. And now we're going to put in for the base L squared, length times length. That's what we're looking for. They'll be the same, so we designate that as length times length, which is L squared, times our h. That's going to be and I call this a tent pole height. So if you think of that pyramid as like a tent, the tent pole would be that perpendicular distance from the base all the way up to the point here that would be holding up the tent. All right, plugging in our numbers. We're told the volume, so we plug that number in. Equals 1/3. We're trying to figure out the length squared. We leave that a variable. Times the height. Height is 144. That's given to us. And now we solve for L. First thing I'm going to do, I'm going to multiply both sides by 3 to undo this 1/3. I'll divide both sides by 144 to undo the 144. And that's going to give me L squared is equal to 2,226,450 times 3 over 144. Then I'll take the square root of both sides, and all I have to do is plug into my calculator the square root of 2,226,450 times 3 divided by 144. And on my calculator, I'll see 215.370 and a bunch of digits after that, rounding off to the nearest hundredth. This 7 right here is in the hundredths place. That 0 make it round down. So length is 215.37 meters. So again, the base will be very long. This is a pyramid, and it is a large scale figure. And that accounts for the length that we get here. That is a lot of meters. All right, Guided Practice 2 doesn't give you a picture. It gives you these words. It tells you that the volume of a right cone is 1,350 pi meters cubed, so it gave us an exact value here. And then it said that the radius is 18 meters, and it says to find the height of the cone. Okay, well, we can do that. I did draw a picture here. I'm going to add a little bit to my picture here. So there's my radius, and there's my height. And so to figure out my answer, I'm going to use my formula for the volume of a cone, V equals 1/3 pi r squared h. Then I plug in what I know. I know that, according to what they gave me, there's the volume, 1,350 pi, and that's equal to 1/3 times pi times my radius that was given to me. That's 18 squared. And my height is what I'm trying to figure out, so I leave that a variable. First thing I'm going to do is I'm going to cancel out the pi's. Dividing both sides by pi makes the pi completely disappear. So we're left with 1,050, and I'm going to multiply both sides by 3 to undo the 1/3, so 1,350 times 3, and I'll divide both sides by 18 squared, and that's going to leave me with h. So I've undone the 1/3 and the 8 squared by multiplying by 3, dividing by 18 squared. My h then can be figured out by multiplying 1,350 times 3 and dividing that by what 18 squared is. It's 324. And that gives me exactly 12.5 meters. And I get an exact answer this time because they gave us a volume in terms of pi, which is an exact value. So there's no rounding that's necessary on this one. Okay, example 3. So this will be our last example, and this one we're asked to find the volume, but we're not given the information that we were on some of the other problems where we were given dimensions like height and radius. This time we're only given the height, the tent pole height here, so the perpendicular distance from the point at the top down to the base on the bottom. And we're also told the angle measurement here is 65 degrees, but we are not told what the radius is. So we're going to have to set about figuring out the radius given that information. So the first thing I'm going to do is I'm going to pull this triangle out of the cone and redraw it down here. So on this triangle here, it's a right triangle. I have legs 16 and R, and I have this angle marked as 65 degrees. I'm going to use my tangent function to determine the value of the radius. So tangent of 65 degrees will be the opposite leg, 16, over the adjacent leg, R. The next thing I'm going to do is I'm going to use cross products. R times tangent of 65 is 16. Then I'm going to divide both sides by the tangent of 65 degrees. That will make the tangent of 65 degrees go away on this side, and it will show up on the right-hand side underneath the 16. So my radius will be figured out by using my calculator to work out 16 divided by the tangent of 65 degrees. Make sure you're still in degrees mode in your calculator when you work that out. Now, on my radius, I was told my height, so now I'm ready to plug into my formula for the volume of a right cone. Volume is 1/3 times pi r squared times h, and there's the base, my pi r squared. So volume is 1/3 times pi times, well, I figured out the radius was 7.46, so I'm going to square that for r squared. My height I was told was 16. Then I plug all that into my calculator. I'll plug in pi times 7.46 squared times 16 divided by 3, and that will give me rounded off to the nearest hundredth. Volume is 931.98 feet cubed. All right, that completes our work here on our guided practice, so it's time for you to move on into the homework portion of this lesson, and we'll see you next time.